In this tutorial, we are going through U-substitution. First of all, what is that? I think the best way to explain is just get into example right away. Say we need to integrate this bulky and spooky looking expression. Well, you might think you can actually distribute and FOIL everything out, and technically you can, but it will take you ages. The best way to solve this is just use U-substitution. And also, when do we need to use U-substitution? You will need it when you cannot find your integral in the standard table of integrals. The point is to set your new variable u being a part of your original integral and express everything in terms of u and du. So, in other words, to get a new integral, which you will be able to integrate. So, that's the whole point of U-substitution. So, what's left over in this case 2x cubed dx, it's gonna be the derivative of this u. Might sound a little bit ambiguous. Let me show what I mean by this. First of all, let's pick your u. As a rule of thumb, if you are given a bracket like here, or if you are given a square root, or if you are given a power of something like sine e, so more likely your u is gonna be whatever you have inside. So in this case, your u is these whole brackets. And what is the point of this U-substitution? The point is to just make your integral simpler in order you can fit it into the table of integrals. Alright, so we're going to set your u being this entire parenthesis, so a half x4 minus 3. The next step, we want to find du, differential of u, by taking the derivative. So we want to differentiate a half x to the 4th minus 3 prime. So the derivative of this is gonna be a half, so by the power of 4x cubed dx. And it simplifies to du equals 2x cubed dx. If you look at your integral, so the rest 2x cubed dx perfectly matches to du. So our goal to express everything in your integral in terms of u and du. This is the whole point of U-substitution. So again, we want to rewrite your original integral in terms of u and du, your new variable. So we're going to replace your brackets with u, and you have this power 8. And the rest is replaced by du. And as you can see, your integral becomes much more easier. So it's just power of u. And remember, in order to take the integral of u to the 8, we want to increase the power by 1. So 8 plus 1 is going to be 9, divided by 9, this new power, plus arbitrary constant of integration, c. Alright, we are not done yet. We have to get back. Since your original integral is given in terms of x, so not in terms of u. So we need to replace your u with the definition of u. So just instead of u, we are going to write the original expression. And that's going to be your final answer. Alright. To summarize, let's just list out the steps. The first step, set your u. The second step, find du by differentiating this expression. The third step, substitute u and du into your integral. And the last step, back sub. So rewrite everything in terms of x, the original variable. Alright, let's have a look at the second example. Say we have e to the 3x plus 2 dx. So let's set your u. So your u is gonna be power 3x plus 2. So the next step, we're going to find du by differentiating 3x plus 2. Remember, derivative of 2 is just 0, derivative of x is 1, and you are gonna left with 3, and we have to attach dx. So look at your integral. Since we have dx, not 3 of dx, so we have to express dx just by dividing both sides by 3. So your dx is gonna be a third times du. And now we are ready to substitute everything into your integral. So 3x plus 2 is replaced by e and dx by a third du. So pull out a third outside of the integral. And all we want to do is just take the integral of e to the u, which remains the same. So it's going to be e to the u. And we have to sub back. So we are going to replace u with the original definition, which is 3x plus 2. And that's going to be your final answer. All right. Let's get this integral. So since you are given a root, let's define your u being this expression underneath your root symbol. So it's going to be 1 minus x to the 4th. The next step, we need to find du. So the derivative of this is going to be negative 4x cubed dx. And look at your original integral. So we are given only x cubed dx. So we are not given negative 4. So in order to match to your original integral, let's just divide by negative 4 both sides. So your x cubed dx is going to be negative a quarter times du. Now everything is ready to plug in. All right, first of all, let's pull out negative a quarter outside of the integral to make it easier. Now we have to integrate 1 over root of u. So remember, we want to, first of all, in order to fit it in the table of integrals, we want to change your root into a power. And since root appears to be in the bottom, we want to bring it up. So remember, the square root indicates a half power. And when we bring it up, your power becomes negative. So it's u to a negative a half. So after using a power rule to this term, you want to get it back into radical form. So it's gonna be 2 square root of u. So we can cancel this 2 and a quarter, so just by reducing by 2. And we are going to replace your u with the original definition, so 1 minus x to the 4th. So that's going to be your answer. There are some problems to work out. More problems?